Alright, this next section we're going to be solving systems with a new method called the addition method. We'll talk about why it's called that in a moment, but let me come up with an example. I think the best way to explain this is just jumping right into it with an example. So I'm going to take the system x plus y equals 7 and 2x minus y equals 5. Okay, and I want to solve this system. Now, let's say for a moment I just isolate one of the equations. I'm just going to take the top equation for a moment and rewrite it. Now, anytime you have an equation, there are lots of properties of equations that we can work with. Things like the addition property, and all that means is you can add the same amount to both sides of the equation. There's a subtraction property. You can subtract the same amount. The multiplication property and division property, same thing. Essentially, whatever you do to one side, you can do to the other side, within reason, as long as you're adding, subtracting, multiplying, dividing. Well, that means I can add anything I want to both sides of this equation. Anything. I could add 1 to both sides, and that's okay. I could add an x to both sides. That would be okay. I could add 12 to both sides, and that would be okay. But I'm going to strategically choose a value to add to both sides. I'm going to add a 5 to both sides. You might say, why did he choose 5? That's kind of a weird number to just randomly choose. And that seems true. But there is a reason I chose the 5. And the reason is this. I have a 5 in the other equation up here. And that 5 is equal to some other stuff. Now, one thing we know about equations is that you can always substitute for something other things that it's equal to. So this 5 is equal to 2x minus y. So anywhere there's a 5, I can replace the 5 with 2x minus y. Okay? I could replace a 5 with anything that it's equal to. And so in this case, I'm going to replace this 5 with 2x minus y, because I know that they're equal to each other. And so now I'm essentially adding 5 to both sides of this equation. Okay, I'm adding 5. The 5 on the left is written in a weird way. It looks like 2x minus y, but because that's equal to 5, I'm really just adding a 5. Okay, so now I can add, I'm just going to add and combine terms. So x plus 2x gives me 3x. Positive y and negative y combine to give me 0y. And on the right side, 7 and 5 gives me 12. What was also nice about this is I have all like terms. Right? So here I have constants adding up, here I have y's adding up, here I have x's adding up. And if I had just left a 5 in there, I would have had an unlike term. Okay. And now I can solve this. Now the term with a 0 drops out, and I'm left with 3x equals 12. And if I divide both sides by 3, we'll get an x value of 4. And of course, we're not quite done because that 4 needs to get plugged back in so we can find the corresponding y value. We need an ordered pair, remember. So I'll put that maybe up in the top equation because I think that's going to be the easiest one to work with. I'm going to subtract the 4 from both sides. We'll 0 out on the left. And we'll be left with a 3. And so it appears my ordered pair, and remember you need your answer in an ordered pair form, it appears my ordered pair is 4, 3. Now let's just double check and make sure that works. This point needs to work in both equations. So if I put a 4 and a 3 in, 4 plus 3 does equal 7, so that works out. And if I put a 4 and a 3 in here, 4 times 2 is 8. 8 minus 3 would give me 5. And so it does work. This is the solution.